So this is the continuation of June 2015 Edexcel International Paper, question 5. The first is just, it's normal distribution, doesn't look too bad. We're given it's got a mean of 55 and only that, so all we really can do with that is draw the standard bell curve. Okay, going through 55 as a mean. So that's part A. No problems there, probably would want to label it. Part B, it says the speed limit on the motorway is 70 miles per hour. Cars can choose to travel faster than the speed limit but risk being caught by the police. Well, we all know that. The distribution of X has a standard deviation of 20. So we have X is normally distributed with mean 55 and standard deviation 20, so variance 20 squared. So this is a pretty straightforward normal distribution question. I'm going to draw a graph as I always do for all of these questions. We're being asked for the probability. Find the percentage of cars that are travelling faster than the speed or a number of cars. So we're finding the percentage proportion of cars where X is greater than 70. Okay, so basically if we draw the 70 here, we're finding what this area is here. Now, that what we do is we transform it to the Z distribution and find what the Z value is. So whatever the corresponding Z number is. So we're finding a probability that Z, and remember the transformation to the Z is equal to X minus mu over sigma, where Z is the normal distribution with mean 0 and standard deviation 1. So that's the probability that Z is greater than 70 minus 55 over 20. So that gives us a probability that Z is greater than 0.75. Right, well, again, drawing the Z distribution there, we can see we're looking for an area which is less than 0.5. That's the first thing. And we know that our tables, which I'll show you up, actually give the numbers to the left of the number. So in other words, the tables that I'll show you here, these tables here give us the probability that Z is less than some, whatever the value is that we're given. Less than Z is equal to A, say. So that's what these numbers give. So we look at 0.75. So if we look at 0.75, well, that's giving us is this area for the Z distribution, where 0.75. But we want the other area. We want this area. Okay, so we're going to do 1 minus to work out that. That's what was the number? 0.7734. So that will be equal to 1 minus 0.7734, which is 0.2266. So question C, we're working backwards because now we're given an area and it says for the fastest 1% of drivers who irresponsibly drive that fast. For you youngsters out there, never speed. It's not a good idea. Not just because you could get called from the police, but because you might kill yourself and someone else. So anyway, let's do the maths. We've got this area is 1% here, 0.01. Okay. Just occurs to me actually on the question, it said it asked for a percentage. Looking at the scheme, you wouldn't have been penalised for this, but I might be inclined to write 22.7% because it asks for a percentage. It does seem as though that was not penalised, but I still wouldn't be taking a chance. If it asks for a percentage, we better give the percentage. Okay, anyway, let's get on with this bit. We've got the lowest speed corrected for a car driver to be banned is 102 miles per hour. So that's basically, we're trying to show that this value, let's call it B, say, where the mean is 55, that the fastest 1% are going to get banned from driving. So we're looking for the probability that X greater the particular value of B, where the probability of X being greater than that is 0.01. Okay, now what we're doing is we're reading the tables backwards. And really we need to find the Z number. Let's change the colour of this. We really need to find the Z number that corresponds to this area being 0.01 for our with our Z. So whatever that number is, what we really need to find, because then we can just relate these two using the transformation. Z is equal to X minus mu over sigma. So we need to find that number. Now, of course, one thing we could do is say, right, okay, I'm going to work out, because these tables here to the right here give the numbers where the direction of the inequality is there. We could look up the number 0.99, but backwards. Okay. I always advise people to do this, or at least look at it before looking at the other tables, which I'm going to show you to get a more precise answer. But 0.99 here, we're looking for a number around about 2.34, something like that, 2.34 or 2.32. Okay, so it's going to be around about that, 2.34, 2.32, but we need to perhaps be a bit more precise than that. And what we have is these other tables here that work unhelpfully in some ways. They're handy numbers backward in this direction here. And if we look at the number 1% here, what that's telling us is if this is 0.01, then this Z value here is 2.3263. It's almost like everything's been reversed. Z is on the right hand side and they're reading from the right hand side here. So that's why I almost like to do it both ways so that we can confirm that it's right. We can see that this does seem to match with this. Okay, so we've got 2.3263 as our Z number. Okay, let's change back to blue now. So we can now say that the probability that B take away the mean, which is 55, over Z is greater than that over 20 is equal to 0.01, and we found this corresponding Z number here. So we found what that represents. So we've got B minus 55 over 20 is equal to 2.3263. Okay, let's tidy this up a bit and make myself a bit of space. So if I rearrange out, I get B is equal to 20 times this number. Add the 55, and that goes to 101.6 0.526, which is equal to 102 to 3 significant figures. So that's that bit done. Okay, so that's part B done, part C done, but then we've got part D, which is also quite involved. So I'm going to make a bit of space for that. So question D is similar, but a little bit more involved, because it says drivers, still people who are speeding, remember, will just be given a caution if they're travelling at a speed m such that they're a certain amount over the limit, but nowhere near to the 1% or 13% over the limit. Okay, where they're over, and so we need to find a value of m such that that's the case. I'm going to do a diagram for it. Oh, I do think diagrams are good here to visualize what we need to do. So we've got 70 is our speed limit. Okay, we want to find the probability, the value of m, such that this here is 0.01325. Well, if we can work out this area, which is not particularly challenging because it's similar to part question A, then the question then becomes very similar to part C that we've just done, because we're working backwards to find an unknown number here. So let's work at what we need to do first is find that area. So let's do that. So let's find a probability that x is less than 70. So that's, I won't make too much of a meal of that because this is very similar. Well, I said part A before, but this is very similar in technique to this. In fact, just looking at it, we've already done it. It's just as well I look back, isn't it? Because that there is always equal to 7734. That's 0.7734. So we've already looked at that number. It's just as well I look back at that, isn't it? So then, effectively, if we're looking for this, we're looking for the probability that the value of m such that this is the case. Okay, now that equals to the probability that x is less than, but let's just say that it's going to be equals to 0, which is just writing the question out. That means that because this is the case, the probability that x is less than m has got to be these two added together. Okay, so that, apologies for me mumbling my way through that. It's a bit fiddly with this stuff sometimes. So that, and now the question becomes very much like the part that we've just done. We want to find, let's just do another diagram. Feel free to do as many of these as you like. So we now want to find m such that this number here is 0.9049. Well, we can see that. If we have a look now, I think we will be dealing with just these tables here because we'll probably find, there we go, 1.31. So we can say that that gives us the probability that z is less than, changing it to zm minus 55 over 20, is equal to 0.9049, just writing the question out and changing with z. That means that this bit must be equal to 1.31. So I get m minus 55 over 20 is equal to 1.31. If I rearrange that, I get m equals to 1.31 plus times 20 plus 50. So that equals to 81.2. So anyone who's doing more than 81.2 will be anyone who's doing the value of that, car drivers will just be given a course if they're traveling at speed between 70 and 81.2. So that's the answer to that question. So I've slightly mumbled my way through that bit, but it does take a bit of thinking through sometimes. Okay, right, let's have a look at the next question. I'll probably do that in another video because that took longer than I thought.